Hi everybody, and welcome to exercise 3 on page 59 of the workbook. Let's read this problem together. So they're telling us that the expected lifetime of a light bulb in hundreds of hours is given by the integral from 0 to infinity of 0.1 t e to the minus 0.1 t dt. And they'd like us to use that fact to find the expected lifetime of the light bulb. Okay, so this particular integral is telling us about the amount of time that we expect a light bulb to last. Okay, notice the units here, hundreds of hours, which will kind of figure in at the end of the question here. Okay, and this would be a really long problem if you had to do it from scratch. So I'm going to start you off with a hint here. And I want you to feel free to use this. If you take the integral of the function, I'm going to ignore the limits for the time being. You can use integration by parts to actually find an antiderivative for this and come up with a function that looks like this. Okay, we could do that by hand, okay, but it turns a problem that's already kind of long into a longer problem, so I'd rather that you focus on the improper integral part of this and not the antiderivative. Okay, so if we use that little hint there, then the integral that we're calculating is going to look like this. So as usual, that's about taking a limit as b goes to infinity, and then integrating from 0 to b of our function. And the next step would be to find the antiderivative to do this integral, but we're going to use the hint and just the fact that the antiderivative is sitting right there. Okay, so I'm going to fill that in. So we'll get the limit as b goes to infinity of our antiderivative, which looks like negative t e to the minus 0.1 t minus 10 e to the minus 0.1 t. Okay, and we'll evaluate that between our limits of b and 0. Okay, now I'm going to do one more thing. Turns out to simplify the algebra a little bit, if we do some factoring before we substitute our limits in, you wouldn't have to do this, but it just simplifies the process a little bit. Notice that there's an e to the minus 0.1 t in both pieces of our antiderivative, so we'll factor that out. Okay, and that's going to let us write this as e to the negative 0.1 t, and then let's see, what's left over is, or actually, let's take out a negative. There's also a negative sign that's common to both of those, so we'll pull out a negative e to the minus 0.1 t, and then what's left over is a t in the first term and just a positive 10 in the second. Okay, now that we've done a little simplifying, we'll go ahead and substitute our limits in for t. So starting with the upper limit of b, so if we plug in b for all of our t's, we're going to get negative e to the minus 0.1 b times b plus 10. Okay, and then the lower limit, let's see, if we plug in 0 for our t's, we're going to get negative e to the 0. That's going to turn into a 1 times a 0 plus 10. Okay, so a couple of things we can notice here. First of all, we've got a minus, a negative here. We might as well put those together into a plus. Okay, so let's do that. And then, if you look at this whole term together, e to the 0 times 0 plus 10, that's going to turn into a 1 times a 10, which is just a 10. And that 10 over there is not going to be affected by this limit as b goes to infinity, and so I'm just going to take that 10 and write it first, and note that really the only thing that we need to take the limit of is this term right here. Okay, we're just making some algebraic observations to help us do this limit a little bit more efficiently. Okay, so we've got 10 plus the limit as b goes to infinity of our expression. And again, notice that we've got a negative exponent. right there. So we can make this maybe a little easier on ourselves by taking that term and moving it into the denominator. So we'll have a b plus 10 in the top and an e to the positive 0.1b in the bottom. Okay, and now we come to kind of an interesting situation that we have not been in before. Okay, we're taking the limit as b goes to infinity of a fraction, and notice that we've got b's in the top and the bottom of the fraction. Okay, so I'd like to think for a minute about what happens in the numerator and the denominator separately here. Okay, starting with the numerator, if you let b go to infinity, what's going to happen to the expression b plus 10? It's going to go off to infinity. And what about the e to the 0.1b in the denominator? That's also going to go to infinity. So we've got a fraction that goes to where the numerator and the denominator both go to infinity. Do you recognize this situation from Calculus 1, a limit of the form infinity over infinity? What do you do to calculate such a limit? Well, infinity over infinity is what you might remember as being called an indeterminate form. We need to use L'Hopital's rule to calculate a limit like that. Okay, so we had kind of a special symbol. H was our symbol for saying we're going to use L'Hopital's rule. How did L'Hopital's rule work again? Well, it was about taking the derivative in the top and the bottom. So we're going to take the derivative of b plus 10, thinking of b as our variable. That's going to give us just a 1. Okay, the derivative of b is 1 and the derivative of 10 is 0. And then if you take the derivative of the e to the 0.1b in the bottom, you're going to get, by the chain rule, e to the 0.1b just times 0.1. Okay, and we have now done L'Hopital's rule, and what we're hoping is it's going to help us to actually do this limit. So let's look at it again. Notice that one good sign is that our numerator just has a constant in it now, and the denominator, e to the 0.1b times 0.1, that goes off to infinity as b gets big. And so the upshot of it is the entire fraction now has the form 1 over infinity, which is going to go to 0. Okay, so we get an answer of 10. And the question is, what does that mean in the context of the problem? Well, the units again are hundreds of hours. And so we have discovered that the expected lifetime of this light bulb is 1,000 hours, which might be better to rewrite as 1,000 hours. Okay, is 1,000 or 1,000 hours. Either way is equivalent. Okay, and there's our answer.